All right, so we're continuing on from what we did earlier this morning, and the whole point of completing the square, and we'll get to it, is that we're going to look at finding the maximum, minimum values of a quadratic equation. So what I wanted to go over first was just graphing our quadratics and then figuring out the max and min values. And so again, a little bit of review here is I'm going to graph the equation x plus 3 squared plus 1. Now, my a value here is 1. But again, this is in vertex form, which we need to find a max or min values. And again, my h value is -3. Again, it's always the opposite, right? And this thing is going up 1. And so if I'm graphing the vertex, I'm going to go left 3 and up 1. So there's my vertex. Now, again, because my a value is 1, that means my steps are actually going to be 1, 3, and 5, because if I multiply each of those numbers, 1, 3, and 5, by 1, I get 1, 3, and 5. So I'm going to go over 1, up 1, over 1, up 3, and it looks like 5 doesn't fit. Back to the other side, do the same thing. And there we go. There's my parabola. Now, here's what we're interested in, is that I want to know the max or min. If it is a max or min value, what is that max or min and when it happens? And what I have is one sentence that answers all those three questions. And so here's the sentence. First off, there is a, and I look at my parabola and see how it dips down and then goes back up. It actually has a minimum value because it goes down low, or the parabola opens up. And as low as it goes is actually a height of 1. And that is when our x value is equal to, and I look over my x-axis here, -3. So that one sentence there tells me I have a min, what that min is, and when it happens. All right, that's the one sentence we're going to be looking for. All right, so try another one here. I'm going to graph this equation here. And again, I'm looking at my left and right number and my up and down number. And this thing is being, again, looks the opposite, shifted right 3, up 6. So that's my vertex. So I'm going to go right 3, up 6. And there's my vertex right there. Again, my a value is -2. And so I multiply my steps by -2. So I'd have 1 times -2 is -2. 3 times -2 is -6. 5 times -2 is -10. Again, just a little review of graphing quadratics in vertex form. All right, so I go over 1, down 2, over 1, down 6. And again, no way -10's going to fit here. So again, on the other side, because the parabola is symmetric. And here's my parabola. But again, whoa, that's ugly. All right, but again, we're all about the sentence. Finding out, does it have a max or a min? What is it and when's it happen? Well, because this parabola opens down, there is a max this time of, and as high as it goes is 6, when x equals 3. Because we go, that vertex is 3 over on the x-axis. And there we go. So again, it's telling us there is a max of 6 when x equals 3. All right, a couple more because I want to get to a point here. All right, so again, I'm going to graph this parabola, the vertex being shifted left 2, but down 5. So left 2, 2, 4, 5, right there. All right, my steps, the a value is 3. So I'm going to go over 1, up 3. And then over 1, well, 3 times 3 is 9. I don't even know if that's going to fit. That's up here somewhere. All right, over to the other side. Over 1, up 3. And again, over 1, up 6 would be our next, or sorry, 9 would be our next step. So it's over there somewhere. All right, I graph my parabola. And again, this parabola opens up. And so again, I'm going to write down there is a minimum this time of, and as low as it goes is -5. And that is when our x value is, we move over 2, -2 actually. Now, notice that our minimum is always this value over here. The min or the max is always this value right there. And our x value is always what's inside the brackets, as long as you know that the sign always looks should be the opposite. And our a value here tells us whether the parabola opens up and down, which determines whether it's a min or not. So again, I'm going to do one more here before we kind of get to the big finale here, or sorry for this part anyways. All right, so again, I'm going to graph the vertex, shift it right 1, down 2. There we go. My a value, see a negative sign here, it really means -1. So my steps are going to be over 1, -1. And then my next step, 3 times -1, so over 1, down 3. Same thing on the other side. And I draw my parabola. There we go. So again, to write down my sentence, this parabola opens down, so there is a max of, how high does it go? It's not very high. It's actually a height of -2. And that is when x is equal to, again, it always looks the opposite, 1. Now, again, here's the key is these min and max values, or when it happens and what the min or max value is, we can see that. That's part of the vertex. The max or min always occurs at the vertex. So in general, a max occurs, a max or a min always occurs at the vertex. That's important. That's why we're going to have to convert everything to vertex form. And then the second thing is, by looking at the equation, if a is less than 0, in other words, it is negative, look what happens. Every time our a value is negative, our parabola opens down, and so therefore the quadratic has a max. And the opposite true is if a is greater than 0, in other words, it's positive, the quadratic, well, it opens up, so it has a min. So we can look at the equation, and just from looking at the equation and examining the a value, we can determine whether we have a max or a min. And then by inspecting where the vertex is, because that's where it always occurs, we can determine what the max is and where it happens, or min, sorry, or max or min, and where it happens. All right, now we're going to get to completing the square.